Okay, so let's have a look at question 4. It's obviously a torque problem. So let's work out what the torque is being applied to start there. So torque is going to be sum of torques. So force times distance. So we've got 80 newtons going up and 80 newtons coming down. Almost a couple, but this length here is 200 millimeters and this length is 300. So 80 times 200 mil plus 80 times 300 millimeters. Whack that into the calculator and we get 40 Newton meters. So that's the total torque being applied. Next, I will need to know the polar second moment of area, so that's my J term. Have a look at that on your formula sheet, and it's given in terms of radius. This is a tube that's being turned, so we need to do inner and outer differences. So you got R to the power 4 outer, take away R to the power 4 inner, and then we'll multiply that by pi divided by 2. Put your numbers in. And the outer radius is 100. Oh no, be careful here. So we got diameters and diameters. The formula's in radius, so make sure we divide the diameter by 2. So we've got 50 millimeters, which I need to raise to the power 4. And then I've got 40 millimeters. I need to raise that to the power 4. Stick that into my calculator and I get 5.7962 times 10 to the minus 6 meters to the power 4. So it's the engineer's torsion equations that we're going to use. So if you recall, that's something like the first 2 bits, I think. So we're going to have torque divided by J equals stress divided by the distance from the centroid, so the radius distance, so we're looking for the stress at. Obviously we're going to be looking for the stress on the outer surface. Actually no, we're looking for 2 stresses here, aren't we? So we're looking for the inner surface and the outer surface, so we're going to use this equation twice. So I've got stress is T over J times R. You could work out this bit first and then times it by your 2 different radiuses. Remember it's radiuses, so you're going to want to divide these by 2. So therefore for the outer I'm going to have 40 divided by 5.7962 times 10 to the minus 6, and the outer will be 50 millimeters, and I work that out to be use my edge button twice, 0.345 megapascals. Answers here in megapascals, and then repeat the same thing in effect for the inner section, just a different number here. If you don't use your calculator, you can use use the back arrow and replace your 50 with a 40. And 0.276 megapascals. So do I have one of them? Oh yeah, I do actually. It's the last one. Outer, yes, it's the last one. Okay, so I'm happy with my answer.